Welcome back to VTU e-Shikshana program on computer aided engineering drawing. So far we have covered in module 4 isometric projections of simple solids and also combination of solids, say triangular prism, triangular pyramid, square prism, and also pentagon, hexagon, etc. and also including cylinder and cone, and also combinations of the same. And also we worked out some problems which are of staircase type steps. Now I have two to three specific problems to solve in this session. The first one is the figure given is top view of combination of solids. One is cylinder is placed centrally on the top of the frustum of cone. So here is the model I have. This is the frustum of cone, frustum of external pyramid and the cylinder. So what I do is I will keep, because nothing is given about the orientation, and here is the orientation, this only we can follow. We can keep the one of the base side parallel to VP, yes, parallel to VP, and keep the cylinder perpendicular to VP like this. Perpendicular to VP. So this is how you get the things. Now the interesting point is this is 15, top edge is 15, then the total becomes, if you project this, total becomes 30, and diameter of the cylinder is also 30. That means in top view you can see the corners are going to touch the top view of the projection of top view of the generators. So in that way you can easily work out, easy to understand. This is the model. Okay, this is the model. Now let me start working for frustum of hexagonal pyramid. Base side is 25 and top side is 15 and the height is 65, and cylinder 100 mm long, diameter is 30. So let me work for the same. Start with a point, then draw lines. Here is 1, 2. So 1, 2, I am interested in 1 to be the starting point. 1, 2 is smaller than 1, 1, 4 is smaller than 1, 2. Okay. So now this is, we must be very careful. 1, 2 is going to house 2 points. 1, 4 is going to 1 point. Similarly, 2, 3 is 1 point, and just parallel to 1, 2 is 4, 3, that is going to house E and F, 2 points. Draw parallels to this parallelogram. You know, isometric projection or isometric view of rectangle is parallelogram. This is 3. Now these are midpoints, A1, D1 points. Mid base corners are A1, D1, and top corners are A, B, C, D, E, F. You can give 1, 2, 3 and A, B, C, D, no problem. Now keep A1 and D1 directly because they are midpoints. In computer also, if you move the cursor, you will get it. Now B1 equal to B1, C1 equal to C1 2, F1 4, E1 3. That these things we have done in case of regular isometric projection of basic solids. This is B1, C1, D1, E1, F1. Join all these in order. So you know these two are isometric lines, remaining 4 are non-isometric lines. They vary in length, do not worry. Then identify the center. Go up by 65 mm to fix the top face. In computer, what you do? You try to scale this. For example, this is 30, this is 25, this is 15. What is the scale value? 15 by 25. Directly you give, it will calculate itself. Now draw parallel to this point. This is OB, base center. This is top center of the frustum. Parallel to this, A1, D1. Along this line only you should get AD. That is information for you. Very easy to learn. Then draw again 30-degree line. Should get on this line, mark the distances, whatever is available here, and draw parallelogram. So this is for top face. Identify the respective points here again. Enclose it in a box and do it. In case of computer, you scale it and do it. You need not do all this. Manually, you have to do this. Now, join all this. Okay. Then join the respective points. So this is A, B, C, D, E, F. AA1, FF1, CC1. Actually, this D1, D1 will be there actually, and this is little bigger. So I will try to solve this. Okay. Now the modified one is this. Yeah. This is DD1. This is BV1. Okay. Accordingly, you get this is rough work. Okay. Fine. Now, before going to complete this, you try to draw the, this is the top face and this is base. Let me keep DD1 and EE1. Now it's okay, done this. Top face don't dark. Anyway, even if you dark, you can change it afterwards. Okay, this is completed isometric projection or view of the frustum. Okay, next, the cylinder you have to place as per the requirement. So this is how you have to keep it. So please observe that the points, corners of this is exactly coinciding with the end generators in top view. That means you have to enclose in a box, means square prism. The square prism, it's like this. So these lines, these surfaces are going to exactly coincide with the corner. Okay. So these corners like this. So you can easily draw the, there are 4 lateral faces for square prism say. I am going to place this square prism surface, lateral surface here exactly. So that is what I am going to do. This is on the top face of this. I am going to draw this one. Easy. Once you complete the box, that is square prism, we can easily create cylinder here. So that's better way of working. Now let me draw lines, 30-degree lines through these corners. 30-degree lines through these corners. Okay. I am creating the lateral surface, one of the lateral surface, that is rectangular face, passing through these corners because of this. Okay, it's easy for me. In computer, what you do is separately you create cylinder and then identify the lowest point line which is going to touch the surface and then keep the midpoint of it exactly here. I will show you on the computer how to do it. Again, draw, take 50 mm, 50 mm either side. Then go up by given value, that is 30 each, because side is 30, diameter is 30. Yes. This is what I am having now. Okay. Instead of having cylinder first, I am going to keep the square prism like this. Okay. The center should coincide with the center of the block, frustum. Okay. Now I have to use 4 centers method. Manually you have to do both. In computer it's easy, I will show you how to do it. Then fix the segments, part of ellipse, 4 centers method, you know. Okay. Now join these conic sections, that is ellipse, by 30-degree line, tangents, that is tangents, 30-degree line only, none other than 30-degree line. So if there is any variation, then the solution is wrong. Okay. Now the final solution is this. Ellipse, again this boundary, again part of ellipse is visible, then again boundary, yes, okay. Then this is top solid, it's over, all visible lines of the top surface is over. Now what about the base solid? Now here is the base, it may be part is visible, all lateral edges, slant edges are visible, this towards you. Then here is the base edges, there will be small variation in the actual because I have taken rough work, okay. A, B, C, D, E, F. D, E and E, F are not visible. Here also same thing. Here top all are visible, but the top face hidden by the top solid is not visible. So this is how you get the solution for this model. So this has appeared in 1 or 2 times in the exam, and also it is available in the VTU book also. Okay, so try to practice this. This is the best way of working. Create one rectangle, that is the base surface. When you keep it like this, that is 30 by 100, treating that this point is touching the midpoint. Now I can give reference what exactly this point. See, here you draw a line, again draw a line. If you draw this point and this point are the reference, that is going to exactly coincide with the midpoint. If you measure this 50 mm, 50 mm, that's what. Otherwise, as I told you earlier, you can take this reference and draw a rectangle. Now this is how you complete the isometric view or projection of the projection means take the reduced length. The view is take directly. Suppose in computer you do it completely with the taking actual length, reduce it by 0.816. That gets you this. Okay, so isometric projection. So it is very interesting to work problems. This challenging to place this. That's all. Here you can do easy. Here also this one. But computer it is easy. It will show you what. But manually it's challenging. Next comes the problem of holes. Now we have dealt with number of problems which are having a block is available, and on that I have placed this, and again I have placed one prism, etc. But suppose that if the hole is there, square hole or circular hole is there, or rectangle, how exactly you draw it? It's again easier. You have to create that shape, that's all. Then you have to create the visible edges. So how it is possible, then we will discuss. Now let me discuss the problem on isometric projection with this as top view and this is front view. Now as I given, say this is the situation. Square pyramid exactly placed at the center. Assume that this is 90 by 90. Have a square hole here, here one square hole, or either way. Diagonals. As given here one square hole and there one square hole of 20 mm each. This is also base is 20 mm. Okay. So this is a block of small thickness, that is 15 or 10 actually I have given. See, just I will give 10 mm thickness. Lesser the thickness, I can clearly show you the whole reference. Otherwise you cannot see the complete lines. Okay. Here also you cannot see all lines, but some lines you can see. That we will discuss. Now this is actually 90 square. Easier, very easy job for us. The plus mark method. Take 45. Take 45 with compass. From this center draw arcs. So one arc and second arc. Then take total. Take total of this, and with the compass placed here, don't lift the compass. Assume that you are drawn here and drawn here. Don't lift the compass. Take the total distance here and draw. Okay, arc. Yes. Yes, I got this 4 points. Top face of the block I got. Top face of the block is ready now. How to create the base? Base, I don't want all edges. I keep only visible edges. Very easy job. 10, 10, 10. Draw this. So this completes the base solid. We don't have complete base solid. I have 2 holes. Anyway, let me take it now. I can complete the pyramid easily. We will do it afterwards. First, let us do this holes. Again, that is also easier. Take again from this, measure 20, 20, and he has given some gap. See, total is 90, 60, 60, 60. In between, some gap is there. After leaving that, draw this square. That's all. Again, take this different measurement and then plus mark. Again, take this measurement and plus mark. That's all. Draw this. Take half of the, that is 10, 10, take total. Only identify these points carefully. So this may be 5 mm. Okay, take 25, 25 here. 25 from this, 25 from this, draw this. That's all. Okay, now take these lines as reference and dark it. Because hole, this is hole. No base, nothing. It is only hole. Then mark 10 mm from this corner down. Because it is a hole, only 10 mm, and draw 30 line, 30 line. That shows the back side of the hole. The front side you cannot see. Here also same thing. Take 10 mm. Suppose that thickness is more, 25 mm, 30 mm or 60 mm. You cannot see. I will show you in one of the case. Suppose that here you have a square prism, isometric or rectangular prism, isometric. Okay. Now I have a small hole, square hole only or rectangular hole. Okay. Now I can see only this part. Because thickness is more, you cannot see complete. Here thickness is small, I can see backside, rear end edge easily. So this shows vertical surface. Vertical surface. Again this shows vertical surface. This vertical edge. And this towards you it's not visible because it's backside of you. So this is about, this just for explanation I have kept the dots. That is to show the surfaces. Okay. Now these 2 holes I have created and completed the isometric view. This is 10 mm. That's why it's visible. Thickness is small, visible. Sometimes it may go up to this. I don't know. It is only rough work I am doing. Next. What about this middle one? That is again the pyramid. Plus mark. It's available there. 10, 10, again 20. Take total and mark. That's all. Then project it up. You will get at the middle. Then it may go up or down. So that depends on the distances. It is 30 is given. So here it is okay, 45. Definitely it will be like this only because it is 45. The height is only 30. It will be below. Now draw this. So whatever the height is given, you have to take accordingly. 2 holes, 1 pyramid. So it can be cylinder, it can be prism, it can be anything for that matter. Frustum of square pyramid they may give, whatever. For simple explanation, I have taken the pyramid. It is easier. It can be frustum of square pyramid also. Now dot all the visible edges. Okay. Dark all visible edges. That's all. So this is about the minimum dimensioning you have to do. This is about the solution. Okay. 2 ends. Now you are looking from this direction. That's what. So either side you have these 2 holes and 1 pyramid. The last one in this session, let me discuss the isometric to orthographic. I have drawn isometric. Very interesting isometric figure. Here I have a base block of this type only, base block of this type, and I have kept one rectangular block, then created a semicircular hole here, rectangular block for a length of 40. If 40 is there, this is 10, assume that is 10, 30 mm base width, and here is 40. And then I have created a circular, semicircular slot. Then we have discussed, we had already discussed this type of things. Then this is the wedge at the end we have kept. Okay, this is the model I have. Then how to draw the top and front views of this. Okay, now let me take the top view first. Okay, wherever cross section you have clear, from there you can start. Okay, it's not necessary to start, or you can mix part by part. You can start with the top view and then go to front view and do it, complete the session. Now let me have, this is the top view. It's a rectangle of 40 by 80. Rectangle of 40 by 80. Yes, top view. What about front view? Front view is again base of say 15 mm height. I'm doing rough work. 15 mm height. Then for total 80, so let me assume that this is 40 length. For a half of the distance, there is we have kept a block with semicircular slot inside. So this is 20. Yes. Yes. Assume that this is 10, 10, this is 20. This is the front view. And one more is left for front view, this inclined slot. Yes, inclined web. You have to back, whether it is backside or at the middle or at the front or complete. So you can see the triangle. Okay. Now I can just say this is surface A. Surface A is over. Then this is surface B. Surface B. Just for explanation purpose, I am keeping that for visualization. Now this is surface C. Yeah, that's all you can see. Then this one is through hole, through slot. You cannot see anything. Then this line will not be there. Suppose if I block it somewhere, anyway, I will do that job for you after completion of this. Small changes we can do and then see how exactly it looks like. Now let me complete the front view. Okay, so front view is this. This front view, this lane is very much there because this is a different plane. Now this plane is not there. Okay, it's open. Now thin lines you can maintain, no problem. Now what about top view? Top view, complete rectangle is available and visible. And now I can start projecting from front view because I am mixing. Start from top view, go to front, then finish something and then again you come back. Now you see, this I am doing. Okay. So assume that this is 15. This radius is 15, this is 5, 5. Okay, as per this. Okay. Now I can draw this for a length of 30. So this is 10 gaps, say 10. Now, yes, this is 10. What about these two lines? Definitely they are available. They are coinciding with the surface. So unlike this, you cannot keep gap. Okay, that is only the front view you can see that. So here is the representation of any circular item axis. If it is slot, square slot, I need not. Okay. Then one more thing is left. See, this one is left. Let me name this as D for D. So for D line is represented by line here, and here is the slot for 10 mm thickness, say. So here you have to draw. Yes. So that's all about the surface. This is representing D. Okay. So the other surfaces you can see, this is E, F. Okay. This is E, F. From top you can see. Anymore, let us realize I have covered the front view, this surface fine, and this surface you can see, and this, none other than this. Now the top view is actually the these two lines, which is representing the semicircular slot. Yes, this one, again the web D, and this area. That's all. Now let me go for small changes here. So here let me have some circular hole in this way. Circular hole. Okay. Let me create a circular hole that needs for particular thing. Say. Now if thickness is small, then you can see the base line also. If not, say 15 mm for this particular radius, it may not be visible. So assume that for thickness it is visible. Yes, this is the hole. Small portion is of the bottom curved surface. I mean circular surface is visible. Curved line is visible. Now how to represent here? Actually you need how much it is from this particular point. Yes, from this point, say this is a total of 30 is there, say this is 15, 15. Then you take then 10, 20. This is the circle. Yes. Then what change you can do here in front view? Because it is circle, definitely there will be dotted line representing there is a hole and also axis. Whenever you have circle, definitely you must show that dotted line. So that depends, you project it and get it. That's all. Next, any more changes I will be doing? Number of changes I can do. Minor changes is going to change the top and front views. Now I will go for one more change. Now, instead of keeping the sharp corner, I will keep this curve. I will keep this curve. So again, this is curved surface, you can see. So it is possible. Then here, if this is curve from this point to this point, then you have to do it. A particular radius will be given accordingly. So in this case, let me take 15 only, 15 from this. Okay. And you can do this. There is no change here. Whether it is curved surface, suppose that it is a curved surface. What is front view? Front view is a rectangle. Assume that it is cylinder. It's a, so here also it is cylinder. You can see only rectangle you can see. You cannot different. Only in top you can see. So this is top view. No change in front view. Okay. I am not going to draw side view actually. So it's easy. Now let me have last change in this figure and discuss. Instead of extending this semicircular slot, I will extend I will keep only up to this for a given distance. Say I leave 10 mm or 15 mm or as per this, say 15, say this one is 15. Here also I keep 15. Okay, now you can see this. This curve you can see they are parallel to this. Okay, now what change? Any changes in the top view, front view? Yes, there is very much change in top view because there is a change in this is free surface, no line edge here. Okay, no edge. Yes. What about front view? Yes, this particular surface is represented by line. I don't think any more changes. This is how you can convert the isometric projection or view to orthographic projection. Okay, so this is about the isometric chapter, and basically you must know how to draw isometric projection of square, rectangle, circle. Isometric projection of square is rhombus. Isometric projection of rectangle is parallelogram. Isometric projection of circle is ellipse. If you know this, definitely you can work out any problem, but only thing is locations, positions you have to keep properly. Okay, in that case you can do any problem in the isometric projection, and will work out the same in the computer. Okay, let me start with the problem of a cylinder placed centrally on the top of the frustum of hexagonal pyramid. Here let us not worry about the dimensions, uh, concentrate on the concept. Here the cylinder is placed on the top, as I explained in the model. We have in top view hexagon uh, of base side and then top face side. If you place the cylinder on it, definitely you cannot see the whatever the below the cylinder, since it is top view. Now if you want, you can have separate hexagon and to draw the base and then scale it and then create this one. Okay. Now to create, this is how you create the hexagonal frustum of hexagonal pyramid of base side and top face side. The height you can create. On top of this, horizontally we keep the cylinder. For that I have taken in this direction. Let me keep in this direction. For that only I have taken the vertical horizontal and created one side of what? Cylinder. Okay, of given dimensions, say 36 here I have taken. Now here this is 16, definitely this becomes 36, that is going to cover entire thing. So this is the square side, you can say. Now what I do is I draw 100 mm long line, 100 mm long line with thin line, you can say, yes, from this point. Even from the center you can do, no problem, but let me keep it from this. So 100 mm minus 30, because inclination is down. Okay, now the type of line you have to change. Must see before starting what type of line. I have taken the thickness but not this one. Okay. Now what you do is create the same thing here. Say this point is a reference, you bring it here, move and fix. You retain this also. That becomes two ends. This is rear end is ready. OR, rear end. Okay. The front end I am going to keep now. So move. You keep this is shade. Yeah, because you would retain there also. Move. You have to move this. Now keep that. Yes, that's all you have to do. Now this is the reference line for me. This particular line I will show you. This is the line contact. This point is the line contact for us. This line is going to place there. Okay, so this one is very important for me. Now let me select the line now, then change it to thin, vertical, normal, thin only, normal. Okay, now draw the 30-degree lines as tangents to these. This line is going to place in this point, with this point. Midpoint of this is to be placed here, that's all, nothing else. Okay. So that line is the line of contact. Now join this with this 30-degree line. Automatically you will get. Line. Join this with the tangents. Automatically this is the cylinder is ready. Now midpoint of this is going to coincide with this point. So move and fix. See. This is what I have done. First, I have taken center only, left, right, center of right, then I created either this way also you can do. Now, that since it is 36, the height of the center line is 18. then you take midpoint of this and then do it. That way also you can do anything. Now I have created this. Now midpoint of this should coincide with the 18 mm height. That's all. Let me review whatever I have done for you. Now let me take this particular component and let me choose this bottommost generator of the cylinder and midpoint of it. Now what I want is midpoint of this bottommost generator must coincide with this. So what we can do is we can copy this and place it here. That's what I have done here. You see, we have copied it and placed it here. Actually you are not supposed to keep this. So naturally you are going to retain this. That is one method. Second method is, as I told you earlier, you can keep the midpoint of the generator, midpoint of the axis coinciding with the height. So here what I do is I have taken the center of the axis, that is center of the cylinder itself, and then coinciding with the height of the cylinder. Height of the cylinder means radius here, isometric radius of the cylinder. Now the combination looks like this. Now the portion which is covered by the top solid is this. See, starting from this point to this point. So what exactly you have to do is you have to remove that. So let me take this portion out. That means you have to retain that with light line. See, this is what you have to do. You have to retain this light line. So this is one way of working. Take the midpoint of the generator and do it, or you can take the center. So what best we can do is, now the one more solid we have taken is this. So we have taken two holes and then one more pyramid. Now in this case, this is the top view, this is front view. Okay. Or you can have vary the height of this. So here there are two holes. That's why there are dotted lines. Next comes the creation of the isometric projection or view of this square block of 10 mm thickness. So first let me take this. You know very well that this is square. You can create with 30-degree line and have this reference. Draw vertical lines for 10 mm, okay, or whatever the thickness given, and create this. Next comes the identification of 3 points. One is center of the pyramid and center of the hole, So how to do it? See here I have created the square here and placed at the respective points. So here there are two holes and one same, this becomes the base of the pyramid and these are holes, square holes. Create this and then move and fix it here, move and fix. Next comes the creation of this. What exactly you have to do is you have to draw vertical lines and then create this. Okay. So here you fix the height and then join the points with the vertex, join the corners with the vertex. So here how to create this? Definitely we can make this by keeping height of the solid, that is square pyramid is 10 mm, then draw two 30-degree lines. That's all we have to do. So here the total combination of pyramid and the square block and creating two holes. Next comes the height. See here in this case I have taken smaller height. If you want you can vary the height and then create. So and also thickness also you can vary. So here you can see very small portion of the bottom edges are visible because thickness is more the thickness. Suppose that this is having 30. Naturally this portion you cannot see. You can see simply a line. So that's how you can create the combination of solids with holes and the projected solids. So this is how we can create the combination of solids, and these are the special problems we are going to discuss. Now here we have the actual figure, isometric projection. If it is isometric view, you take the actual length. If it is isometric projection, you reduce this by 0.8165. So this is how you can have the combination of solids and holes, etc. So thank you.